Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Dear friends, in the previous session, we became familiar with the structured data of the pandas, especially the data frame, the creation of these objects, and the use of the most of the basic operation should be familiar to us by now. Once this knowledge is consolidated, of course, dear friends, it is time to go to the heart of the analysis of this object. So in this session, we will see many of the advanced features of the Panda library that will allow us to manipulate this type of objects in many ways, all in order to obtain information from the results. Okay, let me just go one by one. Of course, we are just going to start with sifting. Dear friends, the data frame is a structured tabular objects and some operations can be performed on it to manipulate the values inside. Among the simplest is shifting, which essentially consists of moving the internal values of the data frame for A1 of a series or by one position. So while maintaining the position of the labels on both the index and the column unchanged. Dear friends, here let me just create a data frame which is essentially done with the sift. So kindly have a note of it. Of course, this is the data frame we have just created. Of course, it is a reshaping of 3 into 3 matrix, and we have just provided the index as in a lowercase, ABC as the index, and to that column in uppercase, that is ABC. And dear friends, the sifting object such as data frame is essentially done with the sift method, and kindly have a note of it. This is the sift method. When on making it, if we want to move the exact value within each row by one position, we will pass the value 1 as the argument to the sift method. So kindly have a note of it, how we are just going to sift it, and we are just going to store that sifted data frame in the DF2. Okay, so kindly just have a note of it, how it happens. See here, and this is the exact sifter, and as we can see, all the values have been translated vertically by one row. The first row has remained empty, and of course NaN is exactly, it is a missing value, while the values that were present in the last row has been lost. So these are several ways to manage these valuation or item losses. So one, for an example, is to fill the missing value with a value decided by us. So to do this, add the optional fill value. That is can also be done. So here, of course, here we are just providing an optional. Okay, so this is a parameter where you can just fill it with the desired value which is going to assign it. And here, dear friends, we have been assigned as 0, and kindly have a note of it what it is going to be done in the DF2 now. So kindly see here, of course, it has been done with 0. And dear friends, as you see from the result, now the elements left empty due to the sifting are set to 0. So however, even in this way, the value of the last row are lost. Okay, so it may be what we want, but it can be an efficient way to move the values of the last row to the first row. How it is possible? Kindly have a note of it. That is what we are just going to do here. And that exact sifted value here, and this exact location has to be moved to the first one. Okay, moved to the first one, and see here, this is how it has been done. And yet another approach is also there. Approach is there. Of course, this is actually depending on the users needed. If it is permanently, if you want to delete with NaN, or the values how you want to be, or of course you can just go ahead with some other missing values or some other sifting values. So kindly just have a note of it, dear friend. First of all, let me just see what is there in the df2. Okay, and this is what the data frame. And when on just making this, okay, so the shift method as default behavior shift elements values vertically down and by a single position unless otherwise specified. So yeah, here we just go, see here it was done. So here we just lost the drop A we provided. So of course the A has been dropped, and yeah, we can also move that element still vertically but in the opposite direction, that is upward. So let me just make it shifting to the upward. So how it is possible is, yeah, we are just going to make use it in a negative variable. So here, so if we want to shift all the values 2 lines up, yeah, we will pass -2 as the mentioned argument. Okay, so we want to shift it to the -2. So kindly just see here where happened, what is that thing? Yeah, of course, I just scroll to that above. See here, this one, 7, 8 and 9, of course it was here, and all the 2 rows that has been shifted. Once if we want to move the values of the element horizontally, that is from column to column, yeah, we will add the optional parameter axis. Okay, so till now we have just done with the row formation, and kindly just have a note of it. Let me just have an examples of an axis 1. So, and here we are just shifting it with 1 and axis 1 towards the column. So see here how it happened. And as we see from the result, the values have shifted to the right, leaving the first column with NaN, that is the missing values. To get the reverse movement, negative integer are also entered here. So let me just enter here as negative values, and kindly have a note of it, how it can be happen. So here too, the management method for columns without values are the same as for the vertical shifting, which we just done in the rows. Okay, yeah. Now let me just move on to the second concept, reshape. See, dear friends, another way to modify the internal structure of a data frame is to modify its size. So this technique is called the reshape. And one of the way to reshape a data frame is to reorder the internal elements, moving the indexing level from column to row or row to column, like that. Okay, now to better understanding this operation, yeah, let's start with a simple data frame, yeah, with a single indexing level, both on row on the column. Okay, so let me just make it. Yeah, of course, here is the data frame df, and we have created with 3 into 3, and of course we have the index as the lower abc and the column with upper. Okay, so let's see how these methods work. Yeah, of course we have 2 methods, one is stack and unstack. Okay, so let me just make use of these methods work, and let me just apply the stack method to this data frame first. Okay, so kindly have a note of it. This is what the stack. Okay, and I'm just going to print it first. Okay, so see here. So how it just shows, I'm just going to have a view of first of all A, and to this value of ABC, okay, to the value of ABC, and then going for the B and to its value of ABC, and next row C and to its value of ABC as 7, 8, 9. Okay, so of course, dear friend, we can see from the result now the indexing level on the rows are 2, while there are no indexes on the column. In fact, the data frame has been reduced in size to a series with 2 indexing level. So the column index has been nested for each label present in the lowest level of index. Okay, now we have under the label A, what we just have, of course, A, B, C, that is the exact column, and same for that for the other B and C also. Okay, yeah, dear friends, in this way, a series of 9 elements is obtained with all the values that keep the label of this starting data frame as indexes without having any loss of information. So, this exact reshape operation undergone by the data frame is perfectly reversible. Apply the unstack method, okay, which does the reverse operations. We get back the starting data frame as the result. So kindly have a note of it. If I just want to unstack it is in the sense, yeah, original data frame. So this is because the unstack method works exactly the other way around, taking the last row index level and transferring to the column. So in this case, since this level is not present, the series is converted back into the data frame. Okay, dear friends, let me just move on to the multi-indexing. This multi-indexing data frame, for an example, with 2 indexing level per row and 2 per column. That is what we are just going to take it as an example. And yeah, first of all, let I just create it. So with the tuples of XA, XB, YA, YB, and of course it is with the uppercase of XA, XB and YA, YB. So kindly just have a note of it, how my multi-indexed data frame is looks like. And dear friend, we have seen that the method stack and unstack convert the last indexing level, okay, present on both rows and columns. But this default behavior can also be changed. In fact, the level to be converted can be passed as an argument. See, for an example, if we convert the highest level of index of the column, here let me just take it as a level 0. Okay, so here if we just make it as like a level 0, okay, in index of the row, the optional level parameter can also be omitted. Okay, so and the integer value can directly be passed to the method. So kindly have note of it. Here we just have the level 0 and how I'm just going to make it as like a stacking. So yeah, as from the result, yeah, you can see the result from this. Yeah, this time it is the index of the column, okay, at highest level. And yeah, when you just make on to the unstack, how you just feel it. So here we just go with the unstack with the same level of 0. So see here, yeah, so the same goes for unstack also. That is, yeah, it is the index of column at the highest level 0 and which is converted into index of rows and put at the last level. That is what happened here. Here we just made it everything. Okay, yeah, fine, dear friends. Let me just move on to the next topic, pivoting. See, dear friends, one of the possible way to reshape a data frame is pivoting. And this process restructure the data frame in a complex way by simultaneously applying the reindex and the aggregation of the internal elements. Okay, so let me just have it. Yeah, of course, here what we have just done is, yeah, we are having something related to the table with red and black, and yeah, of course we have something related to the indexing and the columns. So kindly just have a note of it, what is the data frame. Okay, so let me just move on to the data frame. See here, dear friends, the exact pivoting operation is performed in pandas through the function called pivot table. Okay, I just to show here. Yeah, this is what the pivot table. This is the exact method. And this method accepts several optional parameter such as column is there, which converts the value present in the column to the indexes for the column of the pivot, and the index parameter converts the value of in the column to indexes for the row of the pivot, and the index label of the original data frame are not considered, and for each label aggregation the corresponding values in the starting data frame are aggregated using the function. specified within the optional here, which I just given as aggregation function. What you want, what the exact aggregation function do you want to apply here? Okay, so this is what happening, and let I just execute it by applying this pivot table. Yeah, here it is our data frame, values, index, columns, and aggregation functions has been done, and towards the aggregation function we have applied summation. Okay, so let me just execute it, and here we go. And yeah, you can extend this also, but anyhow, kindly have a note of it, what it happened. Of course, it is just done with the black and to the red, and how it has been done towards the summation according to the C and D and towards the index of A and B. Okay, yeah, fine dear friends. Yeah, as I have already specified, yeah, you can extend the pivot table by applying different aggregations function also for each column of the values, and the aggregation parameter can in fact accept a dictionary also. And yeah, here I have just given an example of dictionary. Okay, so in which the keys or the column, which the values or the aggregating function. If we want to apply more function to the same column, yeah, we can insert a list as a value also. Okay, so here, yeah, we have just given the result of something which we just call the maximum and minimum. Of course, the aggregation as like here we just applied for summation and to the mean value. So kindly have a note of it, how this pivot table happened. Yeah, of course, we just have summation, maximum, minimum, yeah, and mean values also, where yeah, this is the index of A and with the column values of B, and yeah, here we just make the aggregations of this black and red functionality. Okay, yeah, first, next we just go on to the iteration. Dear friend, this exact iteration or structured data. Okay, structured data as dictionary, or more simply a list and n-dimensional array, or in the Python, yeah, all structured objects regardless of their shape or often involved in the implementation that require an iteration that allows access to the element within them. So for the data frame, yeah, we have seen that there are selection techniques that allows us to overcome the system in the most common operations. But sometimes, particularly if we need to implement methods that work in some way on this type of objects, yeah, it is necessary to iterate. Okay, yeah, let me just see how the iteration functions works. And yeah, dear friends, here we have given a series of functionality. Okay, yeah, let me just iterate through a series. Will it just behave the same way as iterating through an array. Okay, so it will directly scan the element inside on which you can operate directly. Okay, so for an example, by applying a function to its value, then of course let's how we can just define it. Yeah, kindly just observe it. Yeah, here is an series is there. Okay, and let I just execute that series. And of course, dear friend, you can loop this one through one level only. Okay, so yeah, of course, by using the for constructor, of course, we are just going to use the for constructor. And when on using the for constructor, kindly observe what is just going to happen. Yeah, to this for constructor, it won't. Let me just apply something, a functional of square root. Okay, each and every time when we just take each of the value in the series, yeah, let me make it towards the square root, and kindly just observe, dear friends. In this case, it is of simplicity. We have just calculated the square root of the individual element. Okay, that is what it happened here. So kindly just have a look of it. And dear friends, the iteration on the data frame instead works in the same way as the iteration on the dictionary. So it will scan the column label like the keys in the dictionary and then operates on them. So how on them itself? Of course, it is in like a column wise. So thus defining a test data frame, yeah, of course, let me just make use of it. So yeah, here it is the same data frame. So let we make use of it by that simple iteration. Okay, and yeah, dear friends, if we perform a for loop in this data frame, this time we will only get the list of the column. Okay, list of the columns onto that labels. Here it is what? List of the columns onto the labels, because we are just passing only the I, that is the label. And in order to access the element contained in the data frame at the lowest level, what we have to do? Yeah, we should apply within that for loop. Which one? This exact I towards the within the for loop. So kindly just observe, dear friend, how we are just going to make it. Yeah, knowing from the previous example, that is I corresponding to the column, and here we just go. Got it? Yeah, in this way, in each for loop, we get a series corresponding to the column selected by the iteration I. And if on other hand, you want to iterate over the element inside the column, you will have to add another level of iteration. That is what here we just say. Of course, it is a nested loop like that. Okay, so it is as like a nested loop. Yeah, kindly just have a note of it. Another level of iteration. So there will be a two nested for loop. Okay, and kindly have note of it how it happens. So yeah, we just need the exact one. So 147, 258 and the 369. Yeah, we are just getting it towards the print functionality. Okay, dear friends, we have seen how it is possible to iterate between elements within the data frame by the means of for loop. That is what we have just seen here in this example. And the Panda library, however, provides method specifically designed to iterate with the data frame more efficiently. Okay, so one among the thing is what? Item. Okay, first of all, let me just create, yeah, the same sample. We are just going to make use of it, a data frame. Okay, so at this level, yeah, the item method allows you to iterate within a data frame at the level of key value pair. Okay, so let me just apply that here. Okay, kindly just have a note of it, dear friends. In the for constructor, we are having two different iteration. Indices are entered, one for the key and one for the value. So which in the case data frames are respectively the label of the single column and corresponding series. Okay, so that is what we are just going to have it. The two indices will be handled by the item method. So let I just execute this and kindly observe here. Yeah, what we have just done in the previous one, kindly just have a note of it. This is what in for loop we just done it as a nested, and here we just done by using the two indices. Okay, this form of iterations allows us to iterate by column using only one for loop. Okay, one for loop. And if on the other hand you want to iterate line by line within the data frame, yeah, we can make use of some more functionalities, that is iterate row and iterate tuples. And this iterate row method works in a similar way to items with a pair of key value iteration indices. Where this time, however, the column label is a key and the value of each single row are used for values, converting them into a series. So this method allows us to iterate row by row through the index series pair. So here it is the exact one. I just to show you the execution. So see here, dear friends, with the same for, yeah, we are just going to make it through this iterate row, and here we having the exact example. And yeah, dear friends, the iterate tuple method is also there, which allows you to iterate line by line, similar to the previous, which we have just seen, the iterate row. And by considering them as a name tuple, okay, this iteration method is more efficient than iterate row. The element of every single column will be directly accessible, calling the corresponding label as an attribute. So while the index label will be accessible via the index attribute, which we just pass it towards the functionality. Okay, and kindly have a note of it. These exact iterative tuples is much more effective. So how it happens? So they are obtained from the iterator, okay, iteration of named tuples. Okay, so whose internal values can be easily accessed as attribute. And of course, dear friend, in this session, yeah, we have just had to know or discussed about what you have to operate on any data frame in maximum autonomy, having understood most of the functionalities that underlie it. Okay, yeah, dear friends, if you want to take your learning to the next level and join us an exciting journey, don't forget to hit the subscribe button and turn on the notification bell. Let's see you on the next session. Thank you, dear friends. Happy learning.